Everybody, welcome to lecture 4, right? We're in our 4th week. Wow, time flies when we're having fun. So I thought I'd start this lecture off with a review of what we've done in this class up till now, and then we'll go into classes a little more. Okay, so we'll do a kind of quick review, right? So we started off at the very beginning talking about computers and talking about computers as calculators, right? And the thing you got to do as a calculator is you got to store data and do operations on that stored data. Operations meaning like addition, subtraction, other stuff. So operations on stored data. And that is what we're going to call a computer. So all of you are in computer science, and that's the science you're in, okay? A computer computes, right? It computes stuff, and you might be thinking, wait a second, but I want to make games and make cool web pages and whatever, right? But all of that is just computations on ones and zeros inside your computer, all right? And so how do we store data? Well, we talked about variables, right? And variables are boxes, right? And boxes that hold values. So they have a label, right? They hold a value, and that's it, getting put into the box, right? So they have a label and they hold a value, and the type tells us how big the box is, okay? And also tells us how to interpret the ones and zeros inside to get the correct value. So if it was 10, for example, and it's an integer, right? So int x equals 10, that's 10 going in there, right? It's labeled x, the type's an integer, all right? So that means it's, what is it? So it's 32 zeros, and the last 4 are 1, 0, 1, 0. That's how you make 10 in binary. So it's 0, 0, 0, 0, 1, 0, 1, 0. And that's in that box, and since we're interpreting it as an int, we see that and we're able to convert it to decimal, which is the number 10. Okay, if that doesn't make sense, just understand that type tells us how big the box is and how to interpret the data. And then we learned how to update variables. So I could say something like, what is this? The center x now, right? Center x. And we would say something like, okay, we want to move this ellipse across the screen. We could say something like center x. Why don't I make this bigger? Oh my god. Why don't I act like I've been here before? So center x equals center x plus 1, okay? And that's saying my new value for center x equals my old value for center x plus 1, right? So it was 10, now center x is going to turn into 11, right? And if it's 11, then center x is going to turn into 12. And we have it in this draw function, right, which is called 60 frames a second. And so we see the ball slowly amble across the screen in the plus x direction, right? Remember, our screen starts at 0, 0 on the top left. It goes down in the plus y direction and goes across in the plus x, to the right in the plus x direction. So x is answering the question how far right we are, right? And y is answering the question how far down. Okay? So variables, right, are these boxes in memory, but from a program standpoint, variables allow us to vary things, right? And anything we want to vary, we'd make a variable. In this case, we're varying the center, right? And then we started out with making this a velocity so that we could vary that and make it, it might jump once or it might jump twice, 2 pixels, or it might jump 5 pixels, right? And then we had to vary the velocity when it hit the wall. And so we had to come up with a condition for that, right? And so we came up with this idea of n if, right, the ball is touching the wall, right, then we flip the velocity. Okay, and so, and we flip the corresponding velocity, the velocity corresponding to the ball, the wall it's touching. So if this ball is touching this wall, it's, and it was going this way, then it's now going that way, right? And the opposite for the way of going up, it's now going down, going right, it's now going left, etc., right? And we did that through some cool math, right? It wasn't too bad. It just took a little drawing it out, where we have the center, right, and our center, and then we had the ellipse width divided by 2, so our center plus the ellipse width divided by 2. Well, if that's greater than if that's more right than the width of the, if that's more right than the width of the box, then we're going to start going the other way because this is touching, right? So we did some simple, what's called collision detection, which is actually a big deal in every game. Think about your games. There's a lot of collisions going on there. So you have to detect collisions. And then things got interesting, right? Because we started coming up with, okay, so we got a ball and we got everything we need to make a ball, right? We know how to update the position, we got velocity, we got the width and height, we've got all these things that describe a ball, and so we can come in and we can make all these variables and we will have a wonderful program, right? And that was fine, and we made a ball and it looked good and it bounced around. We could even change its colors if we wanted to by making the colors variables too, right? And then we're like, okay, let's make ball number 2. Let's have 2 balls bouncing around. Why not, right? It should just be just as easy. And we ended up copying all this code to make ball number 2. And then we said, all right, let's make ball number 3. Okay, now we're just got to do all of this again. And our program is growing giant by leaps and bounds in size and the number of lines of code, and it's not simple. We have this concept of a ball. The ball has these variables in it, right, and has these actions it does, okay? And if we have to keep on doing that, we're gonna have to make the same variables and the same actions for each individual specific ball, right? It doesn't make sense. So that's when we started creating classes, okay? And classes were cookie cutters, all right, that allowed us to create individual cookies. So in this case, we had a class ball, and we said, well, every ball has a center X and center Y, so we're gonna have a center X and center Y. All of our balls have a velocity X and velocity Y, so we'll have a slot for velocity X and velocity Y. Sorry, I was doing something earlier. We'll talk about final in a second. I'm just confusing people. We'll come back to this. All right, and then every ball has an ellipse width and an ellipse height, and so we have that too. And we'll talk about the constructor in a second. Let's do that. Okay, good. I'm calming us down a little bit. Hold on. And we always start with public class ball, right? And we got that, and we got that, and wait, hold on. Did I screw something up? I screwed something up. Act like you've been there before a show. Oh, is it, am I not all the way at the top? I'm not all the way at the top. There's public class ball. Got it. Okay. Sorry about that. And what did they not like about this? What is going on? Oh, I might want to label these with values. let's call it px and py, right? xy is always such a bad idea. Okay, so I'm just naming these shorthand. I know I named them position x last time, just to make it abundantly clear that that's the initial position x value. Okay, but these are our initial values, right? And we could say like center x equals px. Okay, so we have slots for all the variables, and then we had the idea, right? So slots for all these variables, right? And so now we could just say my ball 1, and my ball 1 will have all these variables, right? And we could say my ball 2, and my ball 2 will have all these variables, and we'll be in business, except for how do we construct these things? So how do we initialize these things? Well, that's when we create a constructor, and the constructor takes in initial values for each one of these variables, and we set them, okay? Now, it seems like we're doing an extra step. Why can't we just set them directly? We'll talk about that in a second, but the short answer is sometimes we want to protect the user from setting these to values that might not make sense. For example, when we set ellipse width to a negative number, it kind of works in processing, but then our bounces off the wall were violated, okay? And so we wouldn't want ellipse width to be set to a negative number. So part of what we're going to do today is look at how we stop that from occurring. But we can continue on. So center x equals px. That's the initial center x value, right? We pass that in. And center y equals py. We could say like initial position x, right? Initial position y, initial velocity x, initial velocity y. Ellipse width and ellipse height is fine. So initial position x, initial position y, just to make it abundantly clear what this is doing. And velocity x equals initial position x. Okay, velocity y equals initial position y. And now, what am I doing? Initial velocity x, right? Initial velocity y. And then we have ellipse width equals EW, and we have ellipse height equals EH, right? And so now we can actually initialize. So ball is a variable. We can create a variable of type ball, and we can invoke this constructor, and we invoke this constructor with the new keyword, okay? And that's how we are able to initialize all of these at one shot. So instead of saying int x equals 5, we say my ball 1, right? We declared it up here. My ball 1 equals new ball, and then we pass width over 2 in for IPX. We pass in height over 2 in for IPY. We pass in 3 in for IVX, the initial velocity in the x direction. We pass 2 in for IVY, the initial velocity in the y direction. And our circle, we're going to create a circle of 30 by 30 pixels, okay? And so now we have created our constructor. And so we can do this for both balls, right? We could say ball 2 equals, and then put it at a different place, okay? And with that way, we're starting to decrease the amount of code. We can continue with this, right? This idea. And let's see, I continued with this idea somewhere. Oh yeah, okay. So this is what we did. Not quite. Where is it? I have so many of these running around. Okay, this is what I did last time, and what we did last time, right? Init center x and init center y, right? And we're coming down. We had amount red, right? At the end, you had to vary the amount red, so amount red had to be a variable, right? And you put it in the red slot into color when you put in the RGB value. All right. We came up with the idea that the ball should know how to draw itself. The ball should know when it collides. The ball should know everything about itself, and all we should say is, "Hey, ball, update yourself," and the ball figures all of that out. All right. So we came up with a function called drawBall, and all drawBall does is draw the ball on the screen. pretty simple, right? And we came up with a function called update position. And all update position does is take the velocity and updates the position, just like we were doing before, all right? But now in a member function that acts on the ball, right? And then we came up with a thing called check collision. And what it does is it checks collision in the X direction and it checks collision in the Y direction, okay? And you could update your amount red in here if you wanted it to get more and more red every time it bounced, okay? Because this, if it's colliding in the X direction or Y direction, it's bouncing off a wall, all right? And then finally, we came up with a member function called update. Notice these member functions are all private, meaning they are meant to be called inside the class. And outside the class, we don't even know how it gets drawn. We don't know how the position is updated. We don't know how it checks for collisions. And nor do we care. Just as long as the ball works, we're fine with it. So the only thing we do is we tell the ball to update itself. And as part of that update, it draws itself, it updates its position, and it checks for collisions, okay? And then our program becomes so simple, right, that we can create all these cookies out of that cookie cutter. Here we're creating 6 cookies, right? And then we're initializing those 6 cookies. We're giving them initial values. And then we are updating those 6 cookies, okay? And we can make them more, we can make them less, we could change our width and heights and all of that pretty simply. So now if we hit play, what we'll have is we have all these balls floating around and they're getting more and more red as time goes on, and it's looking pretty good, right? And so we have pretty quickly we have a cool program, except for my computer is dying because 6 balls is apparently too much for it to handle. And so nice, we're in business, right? And so we've gone from the computer and storing variables in memory to getting balls on the screen, right? Which is pretty quickly exactly the kind of sequence that we've gone through in history, right? We started with the calculator, and now we started at the bottom. We started with the calculator, and now we're here, right? With a real graphics program, okay? So now you know basically everything there is to know about classes, right? There's a few little hiccups that we're going to go through today, a few little details that are Java keywords that students don't seem to get often, or kind of see them and not sure exactly what they do. So we'll talk about those next, and we'll use them, and then we'll continue on with our adventure. I think you're going to really like the project this time. So yeah, ask you a few questions, and then I'll see you in the next video.